Researchers at Duke University have demonstrated photodetectors that could span an unprecedented range of light frequencies by using on-chip spectral filters created by tailored electromagnetic materials. The combination of multiple photodetectors with different frequency responses on a single chip could enable lightweight, inexpensive multispectral cameras for applications such as cancer surgery, food safety inspection, and precision agriculture. A typical camera only captures visible light, which is a small fraction of the available spectrum. Other cameras might specialize in infrared or ultraviolet wavelengths, but few can capture light from disparate points along the spectrum. And those that can suffer from a lot of drawbacks such as complicated and unreliable fabrication, slow functional speeds, bulkiness that can make them difficult to transport, and costs up to hundreds of thousands of dollars. In research appearing in the journal Nature Materials, Duke researchers demonstrate a new type of broad-spectrum photodetector that can be implemented on a single chip, allowing it to capture a multispectral image in a few trillionths of a second and be produced for just tens of dollars. The technology is based on physics called plasmonics, the use of nanoscale physical phenomena to trap certain frequencies of light.